Hello, welcome to the class of Advanced Statistics and Econometrics. In today's lecture, we are going to discuss about autocorrelation. We have already discussed about multicollinearity and heteroscedasticity. This is the third problem which is frequently encountered in the regression model, that is called autocorrelation. So autocorrelation, one of the assumptions of the classical linear regression CLRM is that covariance between Ui, the error term of observation I, and Uj, the error term for observation j, is 0. Regions for autocorrelation include, so if this correlation is not 0, then correlation between error terms, that means they are not independent, they are dependent, they are related. So then we call it as the problem of autocorrelation. So region for autocorrelation include the possible strong correlation between the shock in the time t with the shock in time t plus 1. The more common, these problems are more common in time series data, whereas multicollinearity is more common in cross section data. Consequences: if autocorrelation exists, several consequences ensues. The OLS estimators are still unbiased and consistent. They are still normally distributed in large sample, but they are no longer efficient, meaning they are no longer blue. In most cases, standard errors are underestimated. Thus, the hypothesis testing procedure becomes suspect, since the estimated standard error may not be reliable even asymptotically in large sample. Detection of autocorrelation. Graphical method. Plot the value of the residual ET chronologically. If discernible pattern exists, autocorrelation likely a problem. Second up is most commonly used test, that is Darwin-Watson test, and third is Bruce Godfrey test. So Darwin-Watson test D statistics is defined as D is equal to summation T is 2 till n E subscript T minus E subscript T minus 1 square upon summation T is 1 to n E subscript T square. Darwin-Watson test assumptions. Assumptions are: first is regression model includes an interceptor. The regressors are fixed in repeated sampling. The error term follows the first order autoregressive AR1 scheme. Here autoregressive is regressing the same variable on the previous value. So ut is rho times ut minus 1 plus nu t, where rho is the coefficient of autocorrelation between these variable ut. A value, this autocorrelation can take a value, coefficient can take value between -1 and 1. If it is 0, then they are independent. The error term is normally distributed. Here we are assuming that the error term for this regression, that is nu t, that is normally distributed. The regressors do not include the lag value of the dependent variable yt. Darwin-Watson test two critical value of D statistics, D lower and D upper, DL and DU. So lower and upper limit, they are called the lower and upper limit, they are established, and the decision rules are as follows. If D is less than the lower value of lower limit of this test, DL, there probably is evidence of positive autocorrelation. If D is greater than du, that is the upper limit, then there is no evidence of positive autocorrelation. If d is between dl and du, no definite conclusion about positive autocorrelation. If d is between, is greater than du but less than 4 minus du, probably there is no evidence of positive or negative autocorrelation. if d is greater than 4 minus du and less than 4 minus dl, no definite conclusion about negative autocorrelation. If d is greater than 4 minus dl and less than 4, there probably is evidence of negative autocorrelation. D value always lies between 0 and 4. The closer it is to 0, the greater is the evidence of positive autocorrelation. And closer it is to 4, the greater is the evidence of negative autocorrelation. If D is about 2, there is no evidence of positive or negative first order autocorrelation. So these are the decision rules. So D can take value between 0 to 4. If it is 0, then there is positive autocorrelation. If it is 4, then there is negative autocorrelation. If it is around 2, then there is no evidence of positive or negative first order autocorrelation. Second test is Bruce Godfrey BG test. So this test allow for lagged value of dependent variable to be included as the regressor. Higher order autoregressive schemes such as AR2, AR3, etc. Moving average terms of error terms such as ut minus 1, ut minus 2, etc. The error term in the main equation follows the following ARP autoregressive structure. Ut is rho 1 times ut minus 1 plus rho 2 times ut minus 2 plus rho 3 times ut minus 3 till rho p times ut minus p plus nu t. The null hypothesis of no serial correlation is rho 1 is equal to rho t, 2 is equal to rho 3 till rho p, all are equal to 0. So BG test involve the following steps. Regress ET, the residual from our main regression, on the regressor in the model and the P autoregressive terms given in the equation on the previous slide, and obtain R square from this auxiliary regression. If the sample size is large, BG have shown that n minus p times R square is distributed as chi-square with p degree of freedom. That is, in large sample, n minus p times R square follows the chi-square distribution with p degrees of freedom. Rejection of null hypothesis implies evidence of autocorrelation. As an alternative, we can use the f value obtained from auxiliary regression. This f value has p n minus k minus p degrees of freedom in the numerator and denominator respectively, where k represents the number of parameters in the auxiliary regression, including the intercept term. Darwin alternative test of autocorrelation. Alternative test that takes into account lag dependent variables provides a formal test of the null hypothesis of serially uncorrelated disturbances against the alternative of autocorrelation of order P. Post estimation command in Stata. So if you are following Stata software, so the command will be estat Darwin alt comma lags in the parenthesis P. So remedial measures. So one of the remedial measure for autocorrelation is first difference transformation. You transform the variable by taking the first difference. So ut minus rho times ut minus 1 is nu t. If autocorrelation is of AR1 type, autocorrelation of first order, we have assume rho is equal to 1 and run first difference model taking first difference of dependent variable and all regressors. Second approach is generalized transformation. Estimate value of rho through regression of residual on lagged residual and use value to run transformed regression. Third is Navy West method. It generates HAC, heteroscedastic and autocorrelation consistent standard errors. And then you evaluate the model evaluation. You can do the model evaluation and find the remedial measures. And the reference for all this is a book titled Econometrics by Example, second edition. Publisher is Palgrave Macmillan and author is Damodar Gujarati. That's it for today's lecture. Thanks.